Today, we are going to solve a mystery that's probably hiding in your kitchen drawer right now. It's all about mirrors, light, and why a simple spoon seems to break all the rules of reflection. Let's get right into it.
I mean, have you ever really looked at your reflection in a shiny spoon? You pick it up, you look at yourself, and something is just weird, right? We've all done it. But have you ever stopped to actually ask why? What is going on there?
Yep, that's the one. The inside of the spoon flips you completely upside down, but then you turn it over, and the back keeps you upright but shrinks you down. This isn't magic, it's just physics. And by the time we're done here, you'll know exactly how it all works.
Okay, so every good mystery needs some clues. And our very first clue has to do with the star of the show, light itself.
This is rule number 1, the absolute foundation for everything else we're going to talk about. Light travels in straight lines. Think of it like a bunch of tiny, invisible laser beams shooting out from a light source. It's a simple idea, but it's crucial.
So, when these straight lines of light hit a mirror, what happens? Well, they don't just bounce off all willy-nilly. Nope, they follow two very specific, very predictable rules. We call them the laws of reflection. Now, I know this sounds super technical, but I promise it's simple. The first law just means that light bounces off a surface at the exact same angle it hits it. Think about playing pool. The angle the ball goes in is the angle it comes out. That's it. And the second law, it just says the whole thing happens on a flat 2D surface. That's all. These two rules govern every single reflection you've ever seen.
So when you apply those two simple rules to a regular flat mirror, like the one in your bathroom, you get the reflection we all expect. It's upright, it's the same size as you, and it looks like it's the same distance behind the mirror. This is our baseline, you know? This is normal. But a spoon, well, a spoon is anything but flat. And this is where things get really interesting. See, a spoon is a curved mirror. And the moment you curve that surface, you start to bend the paths of those light rays, and that completely changes the reflection you see. A spoon is pretty cool because it actually shows us the two main types of curved mirrors. The inside part, the bowl you eat with, is concave. A really easy way to remember that is it curves inward, like a cave. The back of the spoon, the part that bulges out at you, is convex.
And here's what those two look like in a more official diagram. You can clearly see how the concave mirror surface curves inward, while the convex one bulges out. This is pretty much just a side view of our spoon.
All right, quick anatomy lesson on these mirrors. There are 3 key points. The pole is just the dead center of the mirror's surface. The center of curvature is the center of the giant imaginary sphere that the mirror was sliced out of. But the most important one, the one you really need to pay attention to, is the principal focus, or the focal point. That's where all the magic happens.
And this slide right here shows the single most important difference between these two mirrors. A concave mirror acts like a collector. It gathers up all the incoming light rays and brings them together, forcing them to meet at that focal point. We say it converges the light. A convex mirror does the exact opposite. It's a scatterer. It takes all the light rays and spreads them out, making them diverge. This one simple behavior, converging versus diverging, explains the entire spoon mystery.
Okay, we've got all our clues. We know light travels in straight lines, and we know how concave and convex mirrors bend those lines. It is time to solve this thing.
So let's start with the inside of the spoon, the concave side. When you look at it from a distance, that curved surface does something wild. It reflects the light from the top of your head downwards, and it reflects the light from your feet upwards. Those light rays actually physically cross over each other in front of the mirror. The result? Your reflection gets totally flipped upside down. This is what we call a real inverted image. But watch this. When you bring the spoon really close to your eye, something amazing happens. The light rays bouncing off of it are now spreading out so much that they never get a chance to cross. Your brain, which assumes light always travels in straight lines, gets tricked. It traces those rays backwards to an imaginary point behind the mirror. And what you see is an image that's suddenly upright and magnified. This is what's known as a virtual image. So yeah, the inside of the spoon is a total trickster. From far away, it creates a real image that's flipped upside down. But once you get in close, past that focal point, it switches to a virtual image that's magnified. Its entire behavior changes just based on how far away you are. How cool is that? Okay, now for the back of the spoon, the convex side. This one is way simpler. Because this surface always spreads light rays out, it can never make them cross over. So no matter what, No matter how close or far away you are, your reflection is always upright, always virtual, and always smaller. No tricks, no drama, just the same consistent result every single time.
And there we have it. Mystery solved. The concave inside flips you because it converges light, causing those rays to physically cross. The convex back keeps you upright but shrinks you down because it diverges the light, giving you a wider view of the world.
But this is so much more than just a kitchen party trick. These exact same principles, converging and diverging light, are used in some really crucial technology all around us. Let's take a look.
Ever look inside a car's headlight or even a really powerful flashlight? That curved, shiny bowl in there? That's a concave mirror. They place a small bulb right at the focal point, and the mirror gathers up all that scattered light and projects it forward as one powerful, focused beam. It's using that converging trick in reverse.
And remember what happened when you got really close to the spoon? It became a magnifying glass. Well, that's exactly how shaving mirrors and those little dentist mirrors work. They're concave mirrors, designed so that your face, or your tooth, is inside that focal length, creating a big, clear, magnified image.
And what about the back of the spoon, the convex side? You see those every time you get in a car. The side view mirrors are convex. They make the reflection smaller, yes, but in return, they give the driver a much wider field of view. And that's exactly why they all have that little warning, right? Objects in mirror are closer than they appear.
Our source material sums it up perfectly. That outward curve lets the driver see a way bigger area. You're trading image size for a massive increase in awareness, which is obviously a critical safety feature. That wide view is the convex mirror's superpower.
So we solved the mystery of the spoon, all by understanding how curved surfaces bounce light back at us. But this kind of leads to a new question, doesn't it? What happens when light doesn't just bounce off an object, but actually passes through it? You know, like how a straw looks bent in a glass of water. Well, that's a whole other story, a phenomenon called refraction, and that's a story for another time.